So, hey guys, today we will be going through the topic of gathering and data structuring. So, why do we bother about data gathering and data structuring? Like, you can think imagine if you have a drawer, where you just throw everything that would include batteries or maybe old receipts, pens, rubber bands. Then now I ask you to find a triple battery. So, how long would that take? A while, right? Because you need to sort everything out and then you need to find everything. Basically, you would need to shift through everything. Now, imagine a perfectly organized drawer. So, everything has its place, right? A section for batteries, a section for pens, and a section for keys. So, finding that particular battery now takes only seconds. So, this in a nutshell is what we are talking about today. The data is everywhere, but most of it is like that messy drawer. So, our job as people who want to make sense of the world is to be the organizers. So, we are going to learn how to create those dividers and how to structure our data so we can find instantly what we need, and more importantly so that a computer can actually. So this is just not a theory, but this is the magic behind your Netflix recommendation system, your Spotify discover weekly, and how your navigation app predicts traffic. So it all starts with a well structured data. So as you can see, the data life cycle. So this is basically our roadmap. So the raw event. So everything starts over here. If a user watch a video or a package is shipped, or you even start a task, so it's a raw real world event. Then in the second one, as you can see, data structuring is there. That means log with timestamps categories. So what are timestamps? Do you guys have any idea about what are timestamps? Can anybody answer about this? So no answers. So timestamps are basically the when it happened. For example, like at 7.05 on October 11th, 2025. So that is what timestamp is basically. And the categories are something like the why or what kind of thing happened. Example, like the description of the task, what it happened. So that would fall under the category part. So in the data structuring part, we grab that the raw event and give it a structure. So we add timestamp and category. So then we can put it in a neat row. So then you can see the persistent storage. So now we save that structured data into a file like JSON or CSV. So it just does not disappear. But now it is persistent, right? So to make the prominence of the file, we save it whether in JSON or CSV, that is there according to the requirement. Then we can see the analysis part and the insight part. So this is the payoff. Because our data is structured, then we can now analyze it and create visualizations, so like charts, graphs that give us insights and help us make decisions. So now the messy drawer becomes a powerful dashboard. So first is log granularity. So simple view, are you logging or made a sandwich, or took out a bread, added cheese, or toasted. So this defines the level of detail in each log entry. High granularity provides rich detail but generates more data. Low granularity is simpler but may obscure the important substates. So, granularity means the level of detail in your data. That is what, like, you can, like, in simplest form, that's what how we define it. So, like, the detail, like how much detail your data is, that defines the granularity of a sentence, you can say. So, it is a level of detail in your data, basically. And you can think like it refers to the scale like present in a piece of information, and the more the detailed the data is, the more the higher its granularity is. So now we'll see, like, I hope I'm clear. Share. So now we'll see about the time stamps. So as I've stated what time stamps are, so timestamp is something like what happened at that particular time, because as we know why timestamps are important, because of the different time zones as well, because in Asian countries there is different time zone, but it can be a problem for a global company, right? Because different time zones can lead to irregularities in data. Because if you think like if 7.10 is happening in India, then it might be like it is not same in the other countries. So the professionals use a single source of truth, that is UTC. That means the coordinated universal time. So you can think of this as the prime meridian of time. So we store everything that is UTC. So now how do we write it down? So not as October 11th, but we use a standard form. As you can see in the screen, that is ISO 8601 and 2025 10 11 T 12 dot 32. No, it's okay, 38. So this is something like the king, because it is the brilliant format and a machine readable, unambiguous, and lexically sortable string format. And the Z signifies the UTC Zulu time. So this will be the format for the timestamp, and UTC is coordinated universal time. So this is basically the global standard time, because as I've stated, storing all times in UTC prevents ambiguity across different time zones. So we need to keep that in mind. And as like Zulu time, and yes, Zulu time is simply another name for UTC. Okay, this is not something new. So it is just the synonym of UTC. So do not get confused. So Unix timestamp. So it basically stores the seconds elapsed since January 1, 1970. It is efficient for calculation but not human readable. Yeah, and this is computer's favorite because it's just the number of seconds that have passed since January 1st, 1970. So that's what it does. And the taxonomies and control vocabularies. So as you can see, a restaurant menu has fixed terms. So you can't order a, like as you can see, there is a spelling mistake in chicken burger. So like in tech view, a taxonomy is a predefined hierarchical classification that is provided. For example, as you can see over here, so it falls under the categories part. Okay, so this is something like you can like it is used to prevent another prevent a different kind of mess. So if you imagine you have a text field for category and people start typing, one person types bug and other also types bug and a third types bug fix, are those any different things? But to a computer it is, but it cannot analyze them together. So this is why we use a controlled library, that is a fixed list of options like a drop down menu. So you can think of a restaurant menu, you can't just order something with chicken, but you have to pick from the available options that would include grilled chicken, chicken alfredo, etc., because this ensures consistency. So this is something, the category part that I've discussed over here. So okay, user. So we'll select the project alpha, then the front end part. Then we'll start the timer. So as you can see, the structured data log is getting loaded, and the description, as I've mentioned, that is user. So it is loading as user. Category is project alpha because I selected project alpha over here, and the tags that I selected was front end, so it is displaying as front end. And you can see the visual time spent also, it is calculating. So we'll see other tasks like if we put fix, bug, okay, and we for the tags we need to separate by using commas, and category like should be so like project alpha only. We are keeping for project alpha. Like okay, start the timer. So this is the log, and as I've stated, the more the detail is there, then the high granularity is there. So okay, stop. As you can see, I've selected the category project alpha. So I selected bug fix critical and backend. So this needs to be separated using commas. So now we'll see some more for project alpha. So now we'll see for the client meeting as well. So for this, we will be using the tags meetings, comma, planning. So see, Project Alpha has major portion that it has taken, but client meeting has only taken 9.7 seconds. So as you can see, we categorize. So for this log, we will be using reporting and presentation, start timer, stop timer. So reporting and presentation, you can see. So, so for this, we'll use the tags demo, feedback, and meeting. The timer has started. So now we'll see the cat for the category of learning as well. So tags will be for this. It will be Python, skill up, and backend. Or another task will be adding for learning only. And for this, the tags will be front end, research, start timer, stop timer. So you can see it has been added. So third one we'll use one more for this, and the tags will be database and learning. So now we'll see for the category of admin. So in this, we have created four categories, but it depends upon the task categorization, and you can like on that basis, the tasks can be categorized into different things. So as you can see, the chart has become colorful and it is showing the various, like how their time is being dividing up, like divided across different types of work. So like as you can see, the project alpha, that is purple, this is where you have spent the most time, so it seems that to be your main focus. And learning is in green, so you have dedicated a significant chunk of time to learning and development. Client meeting is yellow, so this represents the time spent in meetings or on client related tasks. And the admin is in blue, so it is smaller but still present amount of time that has gone to administrative task. So this is the perfect example of the insight that we have discussed. So this is the final step in the data cycle, because the data was gathered and then structured correctly with the categories, then you can instantly see a high level summary of your work. So now we will walk through the Python script, so that is used for analysis. So at first we need to import data, import JSON, import time, and import OS. So class time logger is used. Class time logger is used. So wait a second. Okay, so like yes, so over here, so the time logger. So you can think of the time logger as like not just as a script but a blueprint for creating a smart reusable logging machine. So each machine that is or an object so you create from this blueprint knows how to start the task, stop them, and most importantly remember everything by saving it to a file. But the bigger picture is that why we are using time logger, because the time logger is a Python class that acts as self-contained system for tracking tasks. So its main job is to handle the entire life cycle of a task log, that would include the creation, calculation, formatting, persistence, and memory. So, like as I told, and for import, why we are the import is like we are starting by importing necessary libraries. The datetime is, of course, we will be needing timestamps. So for handling all the time related operations, that would be getting current time calculation, like calculating durations. For that all purpose we are using the datetime. JSON is something for like for converting our Python data, dictionaries and lists into JSON format for saving it into a file. OS is used for a simple check to see if our log file already exists or not. The time class time logger I've explained. So now here comes the constructor. So this method is a setup function. So it runs automatically the moment you create a time logger object. The first line, that is def init self. So this special name init marks this as the constructor. Self is a crucial concept because self refers to the specific instance or object of the class. So it's how the object holds its own data. And as you can see, the self file path is equal to file path. That means that it takes the file's name we provide, or maybe uses the default time log stations, and then it stores it into the object's memory as self.file path. Now we'll see about the self logs. So self logs is the memory. This is the memory part actually. The very first thing the logger does is call the another method, that is load logs. So to read any previously saved tasks from the files. So the result is stored in self.logs. And now we can see as self.current task is equal to none. So this is basically it initialize a variable to keep a track of the currently running task. So at the start, nothing is running. So that's why it is set to none. As you can see, this is set to none because nothing is running at first. That's the primary reason. Now we'll see this part. So this is the internal methods. So load logs and save logs. So these methods basically handles the reading and writing. And the underscore prefix is a Python convention that signals that this is an internal helper function and it is not meant to be used from outside the class. So as you can see, the prefix underscore is there for load logs and save logs as well. So the for the load logs, so the purpose over here for load logs is to read the time logs.json file. So it first checks if the file even exists or not. Then if not, like the very first time that we run it, it simply returns an empty list. Then we can see that with open r safely opens the file in the read mode. So single quoted r is used for read mode. Then you can see the json.load f. So it does the magic because it runs the JSON text from the file and parses it into a Python list of dictionaries. So this is for read mode. Then it learns. Then it reads the JSON text from the file and passes it into a Python list of dictionaries. So now we'll see about the save logs. So the purpose of save logs is to write the current list of logs to the timelogs.json file. So with open, W is there, right, in quoted. So it opens the file in write mode. So this overwrites the entire file. Then json.dump self-logs, comma f, comma indent is equal to 2, takes a Python object that is the self-logs and the dumps into the file as a JSON string. So indent is equal to 2, intent is equal to 2 makes the JSON file nicely formatted and easy for humans to read. So this is the core logic, that is the start task and the stop task. So these are the public methods that you actually use to interact with the logger. So the start task is there. So in that cell, name, category, and tags are there. So first it checks that you are not trying to start a new task while one is already running. So the most important line is the start time. So it basically gets the current time using the date time dot now, and crucially specifies the time zones as datetime dot timezone dot utc. So this ensures very times, like every timestamp is in our professional UTC Zulu time. So it stores all the information in self.current underscore task dictionary. So basically it checks if like other task is running or not. So its primary job is that, like, if you're not trying to start a new task while already one task is running. Then we'll see the stop task. So it basically captures. So stop task is something like it captures the end time also in UTC, and it also calculates the duration by simply subtracting the start time from the end time. So this creates a special time delta object. Dot total seconds converts this time delta into simple number, that is 120. Like for example, if 125.6 is there, which is perfect for analysis. So as you can see, the dot total seconds converts this time delta into simpler number, and is O format is like, this is the other critical formatting steps. So basically it converts the Python datetime objects into, as we have discussed above, ISO 860 string format, right? So this is the standard unambiguous way to store a time text, like timestamp as text. So that's what it is done. Then self logs as append is there, that is self current task. So the now completed task dictionary is added to our main list of logs. Then self.save logs. So this is the final step. It immediately calls the save function to write the updated list to time logs.json, making the change permanent. And as stated, the self.current is equal to none. It resets the current task so a new one can be started. So this is what it has been in. So the ISO one, as I've stated, so this is the primary thing that is used for saving the time stamps as text, because of the string format, and it is done by using is2 format. So now we'll see the part 2 with pandas. So panda is a library for Python. So in the first step, we will import pandas as PD. So that is something like it imports the pandas library because the as PD part is a universal convention in Python world. So it's a shortcut. So we don't have to type pandas every time. So you can see the def analyze log. So this defines a function. It takes the file path for our log file as an input. Then we are loading the data. So this is where the detective opens the file exactly. The try dot accept block. So this is a good practice for error handling because the code tries to open the file, but even if the file does not exist, file not find file not found can be printed because it prints a clear error message instead of crashing. And df is equal to pd dot read underscore json file path. So this is the first magical pandas command. So with this one line, that basically opens the time logs .json file, reads all the structured JSON data, then automatically creates a neat organized table that is a data frame and it stores in the variable df. So the df now contains all our logs with columns like name, category, start time, etc. So this is something like which basically opens the timelogs.json file, reads all the structured JSON data, automatically creates a neat organized table, a data frame, and it stores in variable df. So now the df contains all our logs, the columns like name, category, start time, etc. So now we will see the data preparation, that is the pre-processing. So even though our data is clean, but the timestamps are still just text strings, right? So the detective needs to convert them into actual time objects to do any math with them. So as you can see, PD dot to date time. So this is another powerful pandas function. It just looks at the start time column and intelligently recognizes the ISO 8601 format that we used and converts the entire column for text strings into proper Python datetime objects. So now the computer understands them as points in clean and can perform calculations like finding the time between them. Now we'll see about the calculate total time spent per category. So that is where like now the data is loaded. So the detective can also start asking questions, right? So this is the most powerful line in the script because and the Python equivalent to of the donut chart on the web page. So that is something what we saw in the donut chart, right? So it was getting categorized based on the categories and the time was getting distributed significantly, right? So this is the grouping step. So it tells the panda to collect all the rows and sort them into buckets based on their value in the category column. All like as we have seen the all project alpha rows together, all running rows together, all client meetings together, all admin rows together, and the duration seconds as you can see. So this is the selection step. So it tells the panda for each of those groups I only care about the duration seconds column. And dot sum is the aggregation step. So it calculates the sum of durations of rows within each group. And slash 60 is the result in seconds. So we divide by 60 to get minutes. So which is more human readable. So as you can see, this was categorized, right? That is like it is categorized by group by category. So this is the basic grouping that was done. So 60 is used for calculating in minutes because it is more human readable. So that's the primary thing. Now we will see find all the urgent tasks. So this line is for filtering because it is a bit more advanced, right? Because you can see the DF tags. The dot apply method let us run a custom check on every single items in the tags column is there. And lambda tags is equal to urgent tags. So this is a small anonymous function, a lambda for each row, because it looks as a list of tags and checks if the word urgent is present in that list or not. It returns true if it is and false if not. Then the df, the outer df, is the filter itself. So it takes the list as of true false values and uses it as a mask, showing us only the rows from the original data frame where the check was true. Now you can see the average duration also. So this is something like what was the average time that I spent on a task. So this was a simple statistical calculation. The df duration seconds selects the entire duration column, and dot mean is a built in pandas method that instantly calculates the average mean of all the values in that column that is present. And the logger one is done in the part one. So we have done the robust data logging in part one, and part two is the data analysis with pandas. So everything is explained. So this is how the primarily the task log should be structured, and this is how the visualization should be also there because it is getting grouped by the categories: the project alpha, admin, learning, client meeting. So this is a visual representations of the time that is spent on distinguished task by a particular user. So this is for today. So any questions?
Hi ma'am, good evening.
Good evening.
Sorry I didn't join it early. I was about 10 minutes late. Can you explain the introduction you gave us about this in the first 10 minutes shortly?
Okay, sure. So basically, I explained about the data life cycle over here. So as you can see, the raw event is there. So everything starts over here because maybe a user watches a video or a packet is shipped. So you start a task. So it's a raw real world event. And as you can see, the second part, that is data structuring. So over here we proceed with adding the timestamps, categories, basically categorizing and structuring the data that is being done over here. And in step 3, that is persistent storage. So basically, after categorizing the data, then we need to save the file in a format. So that would be JSON or CSV. So that the prominence of data should be there. It just does not need to disappear. So that is why it has been done. And the last, fourth, and fifth thing is the analysis and insight. So this is something like when our data is getting structured, post that we need to create visual structures as well, like charts, graphs. So as in the web page, I've showed you the donut chart, right? So that was categorized by the groups. So this insights basically helps us make decisions. So that was there. And for task logs and granularity is something like, granularity means the level of detailness in a sentence. The level, like basically it means the, like the more the detailed the sentence is, that means the high granularity is present. That is there with and for task logs, and like for timestamps, I we discussed about the key concepts, that is UTC, and why timestamp is important because of the different time zones. So we use a universal time zone over here, that is by UTC, coordinated universal time. So this is the global standard time. Storing all the times in UTC prevents the ambiguity across different time zones. And this is used for like string purpose, and this is a method so that is used, and z signifies the UTC zero time as well for this. And Unix time is something that the seconds elapsed since Jan 1, 1970, and it is efficient for calculations but not human readable. But yeah, computer do use it because of the structure of this Unix timestamp, because it's just the seconds that has elapsed, so it is more machine friendly readable. And the taxonomies and control vocabulary, so this is the category part, so that we have done below. So taxonomy is a predefined hierarchical classification system, so that is something like project, feature, subtask is there. A control vocabulary is a restricted list of terms for bug fix, hotfix, or patch to ensure the data consistency. And for this, and we are you why we are using the categories, because like if you imagine you have a text field for like maybe category, and people start typing front end, like if one people is typing in small, like a bug is being typed in small letters, and the other people is typing the bug in capital letters, and the third person has typed bug face. But are those all different things? To a computer, that is yes, but they cannot analyze them together, right? So that is why we are using a controlled vocabulary, that is a fixed list of options like drop down menu. That means that you have to pick from the available options only. So this ensures the consistency. So over here, as you can see. So this was pretty much about the introduction over here. I hope it is clear to you, Umar.
Yeah, thank you, ma'am. Thank you.
And you needed that path, right? I'm sharing you.
Yeah, and another question is, what are the main stages of data life cycle and how do they connect in the real project?
Sorry, come again.
Am I audible?
Your voice is breaking.
Am I audible, ma'am? Hello?
No, it's still breaking, Umar.
And there may be some network issue. Am I audible now, ma'am? Hello,
Still, it's
hello,
breaking, Umar.
hello, ma'am. Am I audible?
Yes, now you are.
Okay, ma'am. My another question is, what are the main stages of that data cycle, data life
What
cycle,
are the
and how main stages of the life cycle, and how do they connect in the real projects?
what are the
Hello.
main, like I am not able to understand what.
Main stages of data life cycle. Stages.
Oh, main stages you're asking? Okay, okay. So
Yeah.
okay, yeah. So main stages of data life cycle. Okay, I'll explain this and how they connect in the real world projects, right? So
Yeah, ma'am.
that would include the structuring of data, planning as well, and we need to analyze the data types. Then we need to manage the data types.
Ma'am, you are not audible.
Now I am not audible. Hello,
Hello.
hello.
Hello. Now you are audible, ma'am. Explain.
So the main, you can think the main stages of life, data life cycles could be like the data creation itself, right? The first one is the planning. Second one
Okay.
would include the analysis part. Okay, so like
Okay.
we need to see the data, whether the data is cleaned or processed and
Mhm.
it is ready for real world deployment or not, because as we know the data is the primary key and it needs to be sorted off or else it can lead to biasness. Third is storage. Data storage and management should be there. So this includes basically storing the process data in secure and accessible manner, that is there. Fourth one is data analysis. So this is basically where we analyze the data and to derive the insights.
Mhm.
Fifth part would be the data visualization part. So this is where, like after analysis, so we can create the charts. EDA, basically exploratory data analysis, is done over here in the data visualization part. So we need to do that. And then lastly, data archiving and destruction is also there, because if the data is no longer usable, then we need to destroy it. That's how it is done for data lifecycle.
Okay. How will the data lifecycle apply to our AI-powered task management system project?
So this is the basic step, right? So this all is interconnected. So if the data is not right, then how you are going to do it? So like how it will be applied, there is not, like it's not like that it will be not there. But see, if the data, if you are, see, I'll give an example. Okay, so if you are using, like if you're creating the AI powered task management system, for that you need to collect the data, right? So when you
Mhm.
are collecting the data, so suppose if you're downloading it from Kaggle, you're when you're downloading, maybe at that time the rows or the columns are missing, so you need to check the data, right, that time. So that's
Mhm.
how the data life cycles comes in. So plan, analyze, data pre-processing, everything comes in, right?
Mhm.
So you need to
Mhm.
see whether the data you have downloaded is correct or not. You need to do the data analysis over there.
Mhm. Yeah, ma'am.
Got it?
Yes.
And I've
So,
shared the
so
links in the chat box. You can refer to those parts.
yeah, ma'am. My another question is, how do we ensure the quality and accuracy of data through the data lifecycle? Ensure the quality and accuracy of data throughout the data lifecycle. Hello, ma'am. Am I audible?
Yes, yes. Hello, hello.
I said, how do we ensure the quality and accuracy of the data throughout the data lifecycle? How do we ensure?
Okay. So Basically, we can ensure data quality is something that is not. You can say wait. Let me think of an example and then I'll explain you. Mm, So, as you have heard of the principle, garbage in, garbage out is also there, right? So,
Yeah.
we have to ensure data quality and accuracy. It cannot happen in a single step, right? But we need to continuously do process check as well while creating and as well as doing in data processing and cleaning. So that all depends upon that processes as well. As I've said, the example for the data set that you will be downloading, right? So in that also you are applying all the data life cycles processes only, right? You will be planning, analyzing, data management, then you need to store the data in a certain way, then you need to create the Python script, then you need to connect it. So everything is being done. So but before you do the data preparation, then you need to ensure quality as well. So that happens when you check the data, it is there.
Mm.
So that's what I have said. If you download a certain file, then it is missing. So it is how you are going to check. And basically I think that only, because and you can also ask somebody else to review that for as well. So that
Okay,
can also
ma'am.
happen. Basically auditing that
Mm.
is being done. And I
Okay.
think now we need to wrap up the session because I have another session now.
Ma'am, I have a little bit, data life cycle and data pipeline.
Data pipeline is different, right?
Okay. I
Data
didn't
life
even hear.
cycle is something. Data life cycle is like how we are going to do, it is like something like how we are going to process the data for a certain thing. Data pipeline is different.
Okay, ma'am. Now I hope you have gathered my material. Sorry
I have
for that.
sent it in the chat box.
Fireworks.
You can
Mm,
go through that. That is the basics.
how to find the chat box here?
How to find the chat box? It is in the chat box only.
Mm,
Please copy those links.
I,
Did you copy that?
no, ma'am.
Please copy that
I,
fast.
I,
I have
I,
different
I
session
actually,
now.
I am not finding that chat box. So
In the
uh,
screen, it is there only.
here, here isn't, here isn't any link on the screen.
You can check in the right bottom. A chat toggle is there.
No, ma'am, there isn't.
You are connected from phone or laptop.
Yeah, actually, my laptop has been crashed, so I was not able to manage that early. So I was working on it, but it may take time. I am connecting this from my phone.
So
This may
in
be the reason.
the interface is different.
Okay, ma'am. Somehow I have got it from one of my friends.
Okay, yes, got it.
Okay, ma'am. Thank you.
Okay, thank you. I'll wrap up the session. Thanks, guys.